This is Screencast 1 for Unit 1, Lesson 1. And the title of Lesson 1 is What is Science? Okay, we're going to answer a couple of essential questions. By the end of the lesson, you should be able to distinguish what characterizes science and scientific explanations and differentiate between science and pseudoscience. Okay, the first thing that we're going to talk about is what characterizes science. And I'm not going to read everything to you. I hope that you will go back and read all of this on your own. But we're going to pick out some of the more important things. Number one, there's a bolded word that says science. Science is the systematic study of natural events and conditions. Okay? Scientific subjects can be anything in the living or non-living world, and in general, all scientific subjects can be broken down into three areas: life science, earth science, and physical science. Life science or biology is the study of living things. If you'll skip down a little bit, earth science or geology is the study of the surface and interior of the earth. And then skip down a little bit. Physical science includes the subjects of physics and chemistry. Physicists and chemists study non-living matter and energy. Okay, so those are the three major branches of science. And let's go now and talk about what characterizes science, what is considered to be scientific. Well, number one, if you look at the big red bold, you need community consensus. And consensus means that people are in general agreement about something. Okay? One aspect that really sets the study of science apart from other pursuits is its need for openness and review. Whatever information one scientist collects, others must be able to see and comment upon it. The need for openness is important because scientific ideas must be testable and reproducible. This means that if one scientist arrives at an explanation based on something he or she observed, that scientist must make the data available to other scientists. Okay? This allows others the chance to comment upon the results. It allows other scientists to retest the results so that they can be verified, things like that. Okay, if you'll hop over to page 7, okay, the second thing that characterizes science is the use of empirical evidence. That's the second bolded headline. Okay? If scientific evidence must be open to all, it needs to be the kind of evidence all can observe. It must be something measurable and not just one person's opinion or guess. Evidence in science must be evidence that can be gained by the senses or empirical evidence. Empirical evidence includes observations and measurements. Okay, this is what my page 6 and 7 now looks like, so you might want to pause and take a minute to highlight what I highlighted, make the notes that I made. For instance, I wrote over here that consensus means general agreement. I wrote over here, reminded myself of the characteristics in science, even though I numbered them also. They are community consensus, meaning that we generally agree as a community, and the use of empirical evidence. Okay, so now we're going to go on to page 8 and 9. All right, I'm on page 8. What is a scientific explanation? Empirical evidence is the basis for scientific explanations. A scientific explanation provides a description of how a process in nature works. Scientific explanations are based on observations and data. Beliefs or opinions that are not based on explanations that can be tested are not scientific. Let me say that again. Beliefs or opinions that are not based on explanations that can be tested are not scientific. Scientists may begin developing an explanation by gathering all the empirical evidence that they have. This could be the observations and measurements they have made, or those from other scientists. Then they think logically about how all of this evidence fits together. The explanation they propose must fit all of the available evidence. Often, other scientists will then further evaluate the explanation by testing it for themselves. The additional observations and tests may provide data that further support the explanation. If the results do not support the explanation is rejected or modified and retested. Modified means changed it up a little bit. Okay? Consider a scientific explanation for how metal rusts. Rust is a compound of oxygen and a metal, usually iron. Oxygen makes up 1/5 of the air that we breathe. Therefore, rust may form when oxygen in the air combines with metal. We observe that most rusted materials have also been exposed to large amounts of water. We also observe that the rate of rusting increases if the water contains salt, as it does near oceans. A scientist would propose that water causes metal to rust and that salt increases the rate of rusting. How might you test this statement? Okay, and I'm not going to do the whole entire page 9 with you, but I'll walk you through a little bit of it. So how is a scientific explanation evaluated? Okay, first, you're going to look at the empirical evidence. What stuff do you already know? Okay, so think of all the evidence you could gather to support the statement that you're making. Remember that the statement that you're making, or the hypothesis, is that water causes metal to rust and that salt increases the rate of rusting. Okay? So first you're going to look at your empirical evidence, think of all the evidence you could gather to support the statement. Second, you're going to consider if the explanation is logical. Does it contradict anything you know or any of the evidence that you've seen? Third, think of other tests you could do to support your ideas. And then last, evaluate the explanation. Okay? And then there is a little set of questions for you. They're actually already answered for you, but it sort of walks you through that process, so it might be helpful to look at. Okay? Okay, so here's what I've got so far on page 8 and 9. So I would encourage you, if you need to pause it to do some highlighting and some note-taking, I would encourage you to do that. Okay? This is all in your text, but I kind of pulled it out and put it over here on the side. The characteristics of a scientific explanation are based on observations and data, and they are not based on your personal beliefs and opinions. That's very important.